Thanks, everybody. Looks like we've got a good turnout here for Eric Martindale from Blockstream. He's going to be speaking to us about the Sidechain Elements project. So if you're familiar with Bitcoin, you're familiar that there are many, many other cryptocurrencies out there that are sort of running their own networks. And he's really going to tell us how we can leverage the power and security of Bitcoin while still running our own networks and being able to innovate and do new experimental things. So, without further ado.
All right.
Thanks, Eric.
Thanks, Jameson. So I'm actually from North Carolina, so it's really good to have the opportunity to come back home. I come back, maybe once a year or so, and every time it's just more and more beautiful. So the Elements project. This is my primary area of interest at Blockstream, which is where I work. This is who I am. My name's Eric Martindale. You can find me on Twitter. This is my company email address if you want to reach out to me for any reason. My presentations and source code are always made available. I almost always open source everything that I do. The source code for this particular presentation is right there at the bottom, so if you want to reference this later, please do. This is who I work for. These guys are really cool, some of the smartest people I've ever had the opportunity of working with. They also have a bit of a reputation in the crypto space. I don't know how many of you sort of follow the Reddits or the Twitters or whatever, but I'm really proud to work for these guys, and I'm going to tell a little bit about one of the cool things that we've been doing now. All right, so the things I worked on while I was here, an entrepreneur here in the area, and this is before I got into Bitcoin, and these all sort of like bled into my process of understanding Bitcoin. I really think that it didn't take me until I discovered Bitcoin, until I realized the common thread between all of these things. I'm just gonna try to move forward here. So most of these projects were done here in the area. So I learned a lot from the Raleigh-Durham ecosystem and a lot from the people that were here. And then I discovered Bitcoin. So we'll just jump ahead really quickly. You can look at some of these names. You can look these projects up. Let's talk about Bitcoin and what happened when it came into my life. All right? Bitcoin is one of it is the first implementation of a blockchain. Blockchain is described by Satoshi Nakamoto in his Bitcoin white paper as being simply a data structure, a series of blocks that contain transactions that are appended almost like a linked list referencing the previous block in history. This solved a bunch of problems, but everybody got really excited about the implications of blockchain, but kind of strayed away from Bitcoin as sort of Bitcoin came onto the scene. It has these libertarian leanings, it has this sort of political statement about it. It came right in the heart of the financial crisis. And one of the things that Bitcoin solved, and I realized that it solved, was a question of trust. In the majority of business relationships, or in the majority of commerce, you often have to look to a third party to facilitate some service for you if you want to participate in commerce. So this may be your payment processor, this may be your bank in the case of the financiers that hold your business accounting. And every time you have to involve another party, you involve more trust into your model. Bitcoin attempts to solve at least the transactional, the trust problem, by establishing a common point of reference, right? Something that everybody can look at and everybody can see is some sort of truth, and they can verify it themselves, given some assumptions. And what's really interesting about this is that for 8 years now, almost exactly 8 years, the Bitcoin network has been functional, right? There's been about a third of an hour of downtime, quote, quote, where we weren't quite sure what was going on. We had to make some adjustments. But we've been up for 4 nines, right? And that's actually pretty good in general computing, but really good when it comes terms to financial service networks, right? Really good when it comes terms to financial service networks. Nothing else compares. And this is since January 3rd, 2009, when the actual Genesis block was created. The initial white paper was actually published almost a year ago today, as of yesterday, I believe. It was the birthday of the white paper. So, what do we want to do here? Well, you might have some problems in your business ecosystem, and you might see, banks and large institutions start thinking about using this technology, this trustless technology, to solve a problem, to reduce costs, because removing middlemen will help you reduce costs. That's one less party in the loop that will end up taking a cut, a fee, so that can help you reduce costs. So a lot of people are talking about building blockchains these days. But the moral of the story here, and what I discovered through Bitcoin, is that you really want to use Bitcoin's code base. And there's a lot of good reasons for this, but the main one is that this has been a production network with real money on it, under constant attack since day one. And the developers that are contributing to Bitcoin's code base are defending against that constant attack since day one. So they've designed the system, they've added all of the range checks, they've thought through a lot of the problems that you might encounter when you're trying to solve a problem in your business with a blockchain. So you probably just want to use Bitcoin's code base, even if you disagree with the economic principles that Bitcoin has adopted initially. Seriously, let's not reinvent the wheel. We think we understand what a blockchain is at this point. We're 8 years into blockchains. What we really want to do is leverage that work. So how do we do that? So this is where we get to elements. So elements, I usually have this nice rhythm here. It's just a little bit of an excreech. Okay, so elements are composable components. They're features. They're things that solve problems. You might have a need to have a threshold, a board, for example. A corporate board may have, let's say, 7 members. You generally have a voting mechanism to ratify things that the corporate board has put in place. Okay? A feature in Elements, a feature in Bitcoin at large, actually exists to solve this problem. Other problems that can be solved by specific features we describe as elements, and that's where the Elements project gets its name. These are just a few of the representations of some of the elements that have been created as part of this project. So they're just features. So let's talk about sidechains. Well, sidechains are just bundles of elements, those features that solve problems, deployed as a blockchain. We'll get to this concept of a sidechain in a moment, on the Bitcoin network. This is our definition of what a sidechain is. This is the idea that you can create a separate blockchain and hyperlink it back to a base blockchain. Right? And we believe that the Bitcoin blockchain is the best, most apt anchor chain for this type of transaction. Well, what does that look like? So let's talk about the ecosystem. So we have the Bitcoin blockchain today, right? This is a nice functioning network. It's got transactions, it's got blocks. Things, by and large, are moving along as expected. People are participating in commerce and, trading and, buying things with Bitcoin. And then you have this concept of a sidechain. A sidechain is the additional blockchain that has a touch point with that anchor blockchain. So while Bitcoin might have the properties of being completely, might have properties of, say, a certain restriction of opcodes, right, a certain set of features, this sidechain might have a different set of features, a different set of elements that may make it more interesting to certain types of businesses, but not others. It's much more specialized, is the idea of the sidechain. Well, you can move money from that blockchain into the sidechain. You can move Bitcoin from the Bitcoin blockchain into the sidechain, move it around with those different properties, and then move it back into the Bitcoin blockchain. And that's repeatable. There's no reason that you have to have one of those. You can have multiples. So here we have sidechain A and sidechain B, just to represent those simple ideas. Well, you obviously might be thinking that, well, if you can do it to the Bitcoin blockchain, surely you can do it to other blockchains as well. And that's true. In fact, some of our projects are actually sidechains on sidechains, where the tokens are actually moved into one sidechain and then an additional sidechain as part of that mechanism. That's a really interesting model, and we can repeat that to customize the feature set of the particular blockchain that we're looking to use. And if we build this correctly, we can move digital tokens from one blockchain to another without having to lose the trust that we would normally have in the Bitcoin blockchain. So there are a number of ways of doing this. We'll get to those later. And they all have very different, very high gravity implications. So when you start looking down this sidechain aspect, you want to really start thinking about what is the business case that you have, what is the trust model that you have, and where is the efficiency gain that you're looking for coming from. So there's a lot of reasons that you might want to use sidechains. Being that this is, I know I say it's 8 years old and we've got what, over, I think it's $11.2 billion now locked up worth of Bitcoin floating around in the ecosystem with the latest price increases. There are a lot of things that we want to make sure that knowing that there's that much money, we want to make absolutely sure that we're not endangering people's funds when we're making tests or changes or improvements or trying new features. Right? So you might want to use a sidechain for a network upgrade. You might imagine some upgrade to Bitcoin coming out, someone wanting to make an improvement to Bitcoin, and it's a testable idea, right? We've gone through all of our tests in terms of like on the paper, we've used the test network to verify that the whole thing works. Everybody's looked at it, everybody gives it the thumbs up, but there's a really important part of Bitcoin that a lot of people miss, and that is the economic incentives. This is where the game theory comes in. The reason the Bitcoin blockchain stays secure is because the people securing it are paid for their work in the currency that only has value when the system is secure. Right? So there's this like tight loop that keeps people securing the Bitcoin blockchain. So when you upgrade something, you may want to launch that as a sidechain to let people opt into that movement, into that new feature to test it, and then give them the reversibility. So if it breaks, they have the ability to recover those funds, and then you're not endangering the entire system all at once. So this allows us to do rolling upgrades of the Bitcoin blockchain. You can also use it for experiments. The experimental idea is something that really took hold, and this is why you see all of these altcoins. A lot of people want to try experimenting with different economic parameters. Bitcoin, for example, has 21 million base units. Some of the other currencies differentiated themselves by creating more base units, and that's an experimentation aspect. But it's a different economic model, right? So this is where we can start thinking about using a sidechain to implement new economic models, and then having portability between those tokens so that the risk isn't all or nothing, the chain succeeds or it fails and everybody loses their money. You actually get a little bit more portability and more accessibility, more security by using these sidechains, because you actually have a real market, because the chains can support the tokens can be moved from one chain to another. Beta releases. Again, this is very likely to very similar to network upgrades. So if we want to test something as a beta and get experimentation and feedback with the intent of people going back into the old system without losing their money, because it's real money, we have that economic incentive to keep the system secure. So this is what makes sidechains different than alternative currencies and alternative blockchains, is that economic binding. There's a lot of different other ways that we can use sidechains. Every day, it seems like I see a new startup. Or just the other day, I saw a Minecraft server that has an in-game currency that is a Bitcoin sidechain bound to the Bitcoin blockchain, which is really cool. Okay, so let's talk about how this actually works. This is described as the two-way peg, and there are various different models of two-way pegs. Okay, this is the link, the hyperlink between the two different blockchains. So we think about assets on sidechains as the tokens, and there are two types of those tokens. There are issued assets, which are just arbitrarily created, right? They can be, whoever is the operator of that sidechain can create this asset. It can be, we're going to call it RTP points, right? It comes from the issuer, and it can be moved around by the holders, but it's created by the issuer. This is different than Bitcoin's model, where anyone can participate in the mining process to compete for the next opportunity to create the currency. But the sidechain can have multiple token types on a sidechain. Bitcoin cannot, right? We can create arbitrary assets, issue them on this network, and then move them around. Then there are bonded assets. Bonded assets it would be like Bitcoin moving from the Bitcoin blockchain into a sidechain. This is an asset that has some external issuer that is created inside of the sidechain environment or moved into the sidechain environment by some set of code. And then simultaneously, also, that same set of code, that same set of functionaries, you can move that token out and back into the Bitcoin blockchain. And the way this works is when you send Bitcoin from the main Bitcoin blockchain to a sidechain, those Bitcoin are locked, cryptographically provably locked in place in the Bitcoin blockchain. They're not destroyed, they're just locked. And when they move into the sidechain, some new token is issued using the proof that they were locked in the Bitcoin blockchain as evidence to create this new derivative asset. And now it can be moved around with all of these different properties. And similarly, you take that same model and you apply it back in the opposite direction. You can have some cryptographic function that releases the locking of the Bitcoin tokens in the Bitcoin blockchain based on the provable destruction or closure of the coins on the sidechain. And this is the whole principle of this hyperlink between chains, is this compact SPV proof. It's a cryptographic proof that allows us to move tokens from one chain to another. But they both have very, very different security models. I want you to think about this for a second. One of these asset types is issued just by anyone. And so you have to trust that entity to issue it in a certain rate, right? Or to issue it in accordance with the rules either that they set forth and agreed to or the rules that you expect them to. The other, the bonded assets, is cryptographically provable, right? So that allows you to follow the rules of someone else's system and then use your own properties on top of it, but you must, as an output, also match what was originally put in. So it's a one-for-one peg, right? Two different security models. So what can we build with these sidechains? So this is the full list this is the periodic table of elements, if you will. We're still working on this, and there's a few more to come that I think Blockstream will be contributing, but we're really looking for a lot of other companies to start investing in the same space and contributing elements as well. And we're hoping at some point in the next couple weeks that the first community contributed element will be made available. Hope to give you more about that soon. Confidential transactions is probably the most exciting element to me. It allows you to conceal the exact amount, or absolutely cryptographically conceal the amount, the value of the tokens that are traded in a transaction, but prove that it is valid. Prove that it absolutely had the right to spend what it spent. And the only two parties that can see the value of that transaction are the parties that are participating in the transaction. Segregated witness, you've probably heard a bit about. Segregated witness is a solution to the malleability problem. It's an early technology problem in the Bitcoin ecosystem that prevents certain types of transactions from being created safely, such as payment channels. Payment channels are one of the most exciting things to happen to Bitcoin in a long time because they allow the opportunity for very fast, rapidly adjusted, tiny little payments in exchange for things like internet service, data, without having to broadcast hundreds and hundreds and thousands of transactions to represent that per second or per byte transactional update. Segregated witness enables that and was just released in 13.1. I will talk about that in a bit. Relative lock time, that's another one. Allows you to lock tokens on a sidechain for a period of time that they cannot be spent until some future date. Schnorr signatures are an experiment in optimization and an improvement to multi-signature. So you might imagine that 5 of 7 use case. That works fine today in Bitcoin. We can create that on the Bitcoin blockchain today. When we start getting up into cases like 500 of 1,000, You start to look to things like Schnorr signatures because they are able to represent the cryptographic work that's necessary to have that many signatures in a much smaller space, which is why Schnorr signatures are both an experiment in optimization as well as an expansion of feature set for the multi-signature functionality that Bitcoin currently offers. There's a whole host of new opcodes that we've created. Question?
So with segregated witness, so clarify my comment. You're looking for miners to move to that level of the Bitcoin code base. And is that true for all of these element projects, or why segregated witness and why not others, and so on and so forth?
So a good portion of these elements make sense in the Bitcoin ecosystem, some others may not, right? So what we're looking for is we're asking companies to either use what has been created so far, or come up with new use cases or new applied cryptography tools that can be created, and then make them, expose them in the sidechain environment so that they're more easily used, right? So that real applications can be built on top of them. We're not asking miners necessarily to become core developers. We're not asking, payment processors to become core developers either. We're not asking merchants. We're not asking consumers who use Bitcoin to become that. But we are asking for, the larger entities that will be taking advantage of this technology in various aspects to invest back in the open source ecosystem. And that's what the Elements project represents, is the open source kernel for blockchain development. We're hoping to basically have an entire network of sidechains that all are trying many, many different things, and the things that really work well rise to the top, and eventually some of them may make their way back into Bitcoin. Some of these others are fairly nuanced and technical, so I will avoid them for now. But we have a whole host of new opcodes that do various things. We have, for example, a deterministic random opcode, which is useful for a number of reasons. We also have opcodes that people have cobbled together virtual machines with through long, complicated, very large and expensive scripts, at least on the Bitcoin blockchain. But it can be done. And that's what the whole point of this Elements project thing is to get that stuff into the open so that more people start experimenting with it and we start discovering things about what's possible faster. Rootstock. This is one example sidechain that I love to talk about because they really unify the ecosystem in a way that I think a lot of people aren't talking about right now. Rootstock is a sidechain that runs the Ethereum virtual machine on a Bitcoin pegged blockchain. Okay? That means you can take Ethereum scripts and run them effectively with Bitcoin's security model. This is a really interesting company. You should go check them out. So what's a way that we can test this stuff today? Elements Alpha, okay, is a public sidechain that we launched over a year ago at this point. Okay, it's pegged to Bitcoin's testnet, so it's not pegged to the main net, so you can't move real Bitcoin into it, but you can move test Bitcoin into it. We launched it on June 1st last year. Oops. I used to have birthday slides here, but since it's so much past June, I guess we'll just have to call it a happy birthday and a half almost. But yeah. Segregated witness. This is a great example of something that was launched last year on the Alpha sidechain. And later, I'll give you the full timeline here. Later deployed to the Bitcoin blockchain. You can see the sequence of events. We built our first prototype in Elements, right? We had an idea for how to solve this problem. Something that would fix the malleability problem. So we deployed it to the Elements sidechain in June, or to the Alpha sidechain last June. It seemed to be working well. We ran all of our tests on top of it. We built a bunch of stuff on top of it. December, at the Hong Kong conference, we proposed it to the Bitcoin community. We said, hey, we think we found something that's really useful for Bitcoin. BIP 141 was created. On June 6th, almost 6 months later, we got it accepted into Bitcoin Core, and that was really exciting. But more interestingly, very recently, we got it actually deployed in Bitcoin 13.1, which is now being deployed and has an activation date somewhere in December, hopefully. What's another one? Op, check, sequence, verify. This is a good one that was really powerful, really interesting to some of the folks building Lightning channel, or Lightning, as well as other payment channel stuff. Similar timeline, we got it activated on mainnet as of block 419,328, which is great because now people can start playing with what I think Taj said was version 1 of the Lightning network, okay, which is really exciting. So people are starting to work on that in the industry, and we're starting to see that emerge, being built on top of Bitcoin.
So when you say it's accepted in the Bitcoin Core, that means you're de-elementifying it, right? And adding it to the main code base.
Yep, so the element exists in our code base, which is somewhat divergent from Bitcoin's code base. So we bundled up that code and then merged it into the Bitcoin code base and then submitted it as a pull request. They clicked merge and accepted it after some discussion and some changes, of course. So for example, segregated witness, we had an implementation in Elements that ultimately ended up, after much discussion, changed fairly significantly when it made it into Bitcoin. And so we had to go back and update our implementation as well. But there's a decoupling there, there's a separation. Because our code is separate, we have to submit it as pull requests anyways, right? This is one that I got really excited about. Segregated witness is also super cool, and there's a few others coming in the pipeline.
Why is that not part of the Bitcoin Core
dialogue? What do you mean part of the community? Why is what part not part of the community?
This is separate, but it sounds like it should be just part of the Bitcoin Core.
That's a great question, and that's honestly some common point of discussion. Is what we want to do internally is we want to we have a rough process in the Bitcoin Core community around BIPs and how code gets submitted and how but it's very rough right now. It's very painful for a developer to go through in some cases. Elements.
Use the governance of it.
We don't think about governance at all. We have our own project, and we think of it as an experiment. We think of it as a communal place where people can come to and test new ideas, see if they work, and then have a clear pathway to getting them back into the Bitcoin ecosystem.
This allows you to bypass the governance, but we experiment over here. Essentially, it's a sandbox with a real underlying.
That's right. You have the real underlying infrastructure behind you, but you have the separation in the space to just do things fairly freely, which is nice. And it would be nice at some point if we had some sort of Bitcoin Core-led project to formalize how these things are created, but we don't have control over Bitcoin Core, much to many's disagreement, but we don't. So.
That's good.
It helps block the NSA.
Help the NSA?
It helps block the NSA.
Oh yes, exactly. Privacy, cypherpunk principle #1, right? That's what we're going for. So let's talk about that. That's actually a great segue. So let's talk about confidential transactions. Okay, confidential transactions is my shit. I love this. So it conceals the transaction amounts, right? The amount of Bitcoin or whatever token you're sending, but it does not conceal the sender or the receiver. So there is further work to be done to improve the privacy model here, but I think that this is a significant step forward because at least now you can't see the values. And so generally, when this is enabled, you generally want the entire sidechain using it, right? Because otherwise, if there's only one transaction in the network, you can see all the inputs, you can see all the outputs, kind of defeats the purpose. So when you have large volume of users of a sidechain using confidential transactions, it's really useful because it means nobody knows how much money is where. which means that your attack surface is much more confusing for anybody who wants to steal somebody's money or exhibit coercion or other things. So it can be combined with other elements and other features like mixing, coin join, you can even do merge avoidance for better privacy. And there is more work to be done in this area. Some of the Blockstream is continuing to work on some, you might have heard of Mimblewimble, for example. Mimblewimble is one of those things that's based on this work. That is now being proposed as a Bitcoin sidechain. So if a Mimblewimble sidechain were to be created, you could move Bitcoin as your Bitcoin in your Bitcoin wallet as you have it today into the Mimblewimble chain, move the Bitcoin around in that Mimblewimble chain in that super secure private environment. You wouldn't get smart contracts, but you would at least have a very private currency. That's nice. And then you can move them back out into the Bitcoin blockchain. It's based on applied cryptography principle known as confidential values, which is a complicated, it's actually really not complicated, it's actually fairly simple. It's a combination of range proofs, which is a very old cryptographic technology, and then another type of, can't remember the specific scheme, but it's a combination of two very old, trusted modes of cryptography to create something new. So rather than a lot of these new cryptography schemes you see are new crypto and they haven't been tested, right? What you want is you want a mature crypto. So we looked to some of the older stuff and we found some meaningful contribution that we could make, and that was confidential values. The implementation in Elements is called confidential transactions, and we're hoping that there will be future work in the very near future that we will be able to talk about. So
there's been work on, what's cool about this is that it doesn't need to be like 90% of network. It can still exist, but it can still be used. Is there a percentage where this needs to hit or becomes useful cryptographically?
I'm sure there is some like sweet spot, but no, there's not much research into this right now because we don't have a production network. And so the next step is, of course, getting a production network up and running that is utilizing this. And we have some commercial efforts underway to do this in big ways. But what we're also looking for is more others to do this in different ways than us as well. So Elements projects, just like my presentation, is all open source. Everything that we do, including for our commercial work, we publish upstream back to Elements. These are the two URLs that you'll want to get tapped into. This is, we have a Slack. Some of you probably are members of too many Slacks already, but chat.elementsproject.org will get you a place to type in your email address and get an invite. And then, of course, the GitHub repo. That's where everything lives. That's where the documents, that's where the source code lives. But that's also where the actual proposals take place and the discussion around the different elements that exist takes place. So with that, that's it. And I'm ready to move into more questions, discussion, and general whatever. So.
I was kind of curious though, what kind of open source security, is it tied to OpenSSL standard cryptography?
So when you ask, so the question is, about security. What kind of security are you asking about? Is security of the network or security of the math?
Yeah, the algorithms like RSA, for instance.
Sure. So right now, so we'll go back to the Elements projects, maybe if we can move fast enough. So the answer, yes. So we're using a lot of the same crypto that Bitcoin is. So this is elliptic curve, SCCP 256 K1. So the changes in crypto that we're using are the Schnorr signatures, the confidential transactions, but they use a lot of the same building blocks that you're familiar with, and they're all standardized. So the SCCP 256 K1 curve is just a different parameterized curve after the same model as the official R1 curve, which was issued by NIST, which is questionably trustworthy. So a different initialization was chosen, and that's what became Bitcoin. Similarly, we're doing the same thing with Elements. We're using the K1 curve just about everywhere. So if our crypto is broken, so is Bitcoin's, and so is a lot of other things. So we're tightly bound.
The white paper, that's the question we're looking online.
Bitcoin.org/bitcoin.pdf is the Bitcoin white paper. Yeah, if you're a webmaster or you manage URLs, keep them nice, clean, simple, memorable, and don't break them.
What are your comments about updating that white paper? I've read some things on Reddit. People want to sort of adjust it or modify it to be more relevant to current time.
Hey, we have version control for a reason, right? I don't have a strong opinion about, whether or not we should touch that white paper, right? Like, I think that if there's a change to the protocol that's made as a non-contentious decision by the community, then yeah, absolutely, we need to update the documentation, right? And let's make sure it's under version control. But let's make sure that newcomers aren't confused by the current state of things. So I don't have a strong opinion either way personally. I don't think anybody I'm actually reasonably confident because I think I know the whole dialogue that you were talking about, and nobody at Blockstream really is interested in specifically updating the white paper, to my knowledge. But I do support this idea of updating documentation and keeping it up to date. Because as you said, if somebody's got that hyperlink, and they follow a link, and it's not up-to-date information, that can be detrimental to the ecosystem.
Sure. Yeah, could you just back up a little bit to show us the chat, actually make forward.
Yeah. Oh, the two links?
The two links, yes.
Yeah, there they are. Question in the back.
Yeah, you're talking about rootstock.
Yeah.
And I guess you said that you get Ethereum security model with the EVM. I guess I just wanted you to elaborate on that, what you meant by it. Is there any advantage other than just multiple Bitcoins to the EVM?
So the question is whether or not you get Bitcoin, I think it's Bitcoin security model with the EVM, right?
Yeah, so what do you mean by that? What do you mean by Bitcoin security model with the EVM?
So you get the mining power of the network, right? And the Bitcoin mining network we view as being more unassailable than others, which have much lower hash rate and hashing capacity. So we view Bitcoin as being significantly more secure just from the pure computational capacity involved. So you get access to that when you anchor something into the Bitcoin blockchain, right? When you put something in this immutable database, you know that it's going to stick there because of all of this hashing power that's being expended to protect it. You would trust Bitcoin over, say, Primecoin to do such a thing because the computation, the challenge of reversing the blockchain, like rolling back things in the Bitcoin blockchain, is so much higher. So you know that the data you put there is going to stay there. And that's the value of the Bitcoin security model over the others. And should something else surpass it in terms of that computational capacity, there is no reason why these things couldn't be constructed on top of it. But my thesis is that you just simply want to use the strongest, best one, right? That Bitcoin is a shared resource for everybody to use. And for that reason, we should test and experiment in the margins to focus on improving the core. And if one of them happens to get stronger and better, now we can just like we did with some of the tokens earlier, we can move the tokens by user choice into that sidechain and get that transition, that upgrade, right? Does that answer your question?
Yeah, you go ahead.
So, I guess when you're talking about sidechains, are you talking about specifically chains that are merged with Bitcoin? So they're using that same hashing power, or are you just talking about a two-way peg between chains that are merged with, that are mining with different hashing power?
So the question is whether or not I'm referring to explicitly the two-way peg or other peg models, I guess, is the question. So there's the federated peg, which is the model that most sidechains are using today, where there's a set of signers known that will both allow tokens to be created in that sidechain as well as withdrawn. right? So that has a number of benefits and weaknesses. There is also the compact SPV proof, which is a thing of ongoing research. And there is also the purely permissioned model, which is, there's one trusted entity that is the sole person that you have, or sole thing that you have to trust to move tokens in between, right? And you have to trust that they're doing everything correctly and safely. So the federated model is kind of in between. It's a holdover for now to allow us to have a transformed trust model in the sidechain itself, but still use Bitcoin's trust anchoring properties for timestamping and immutability until such time as we really nail down and figure out exactly what the models for the compact SPV proof, the truly decentralized pegging mechanism is. That's taking time, and there's a lot of people working on that. And we don't want to just deploy it without, like, making sure that it works. So that's what we're really going after here. And the Bitcoin blockchain's trust is the highest that there is to use right now. So what these sidechains allow us to do is test and experiment new models with only minimal reduction or slight transformation in the security assumptions, right? So that's really what we're talking about here. We have a question here before we move on.
Yeah, actually, sort of following up on that, then does that mean that every sidechain that exists now relies on some sort of human's active governance of it then? If you're talking about the federated model?
So the alpha sidechain, at least, I can say yes to that question. However, there are several other sidechains. I think Rootstock is also adopting the federated model, but there's also the other proposals that are going out there to figure out how to do this in a way that we'll probably have to change Bitcoin. We'll probably have to add an opcode of some sort to make this really work. But there is research going into figuring out how to do it in a way that we can just get rid of the federation. But then these other questions come into play as to, like, the game theory, right? So for example, merge mining. This idea of merge mining is that you have two separate chains, and the miners, rather than throwing their weight on one chain and then you checkpointing into that chain, the miners will actually mine both chains. The same work can be applied to both chains to produce a proof of work in either chain, and if the block, if you're successful in that proof of work, you get the tokens or you get the reward for the corresponding chain, and then you can pool that. And there's all sorts of different complications there. The question is, does that diminish Bitcoin's security model? Does that diminish the trust model available to the main chain? Because now you're assigning mining capacity to this other network, and it's entirely possible that if you have a proof of work-based sidechain, that you can decrease the security of the main chain by pulling miners away from it. Right? By pulling miners away from the main chain towards the side chain, for whatever reason, we have to be very careful with the incentives here, and that's what's taking it time and energy, and we have to really figure this out, because otherwise there can be unexpected complications with the trust anchor, right? You can't cannibalize the resources. I think I saw another hand up over here.
So sidechains, are they invisible to the network?
Sidechains are invisible to the network.
So no one knows how many sidechains there are.
That's right.
Except for maybe alpha, the
very public ones, that's right. So sidechains can be implemented, or are currently implemented as it looks like a multi-sig account on the Bitcoin blockchain. And you can't differentiate that from any other multi-sig account. So it's hard to say, but we are very early. I can probably say with some confidence, I could probably count on at least my two hands current number of sidechains out there. There are tons of people working on others, tons of people working on other security models, and what we think we'll see is an explosion in the number of sidechains that are out there, because this protocol, this fact of being able to move things from one network to another and transform their properties is pretty powerful and compelling, because it's no longer about competition in a direct sense, but now it's about, okay, let's move to the most specialized use case and continue moving and moving, and then service providers, businesses can crop up to provide those specialized services, to provide those innovations such that those specialized services are possible, and then subsequently we now have a stronger ecosystem as a whole, and that's really what we're after.
So a second question, is there a way to do a smart contract that turns into a sidechain? If that makes any sense at all.
I think I see where you're going with this. Let's find out, right? Like, there are many ways to, once you have this computable money, programmable money, you can do so much with it. It's really incredible. And when you really model money as just information, then things really start to get interesting, and you can start transforming all sorts of different, from money into smart contract into whatever. So yes, the answer is probably yes, but let's go out and build a prototype and figure out, like, how can we make that available to everybody so we can all leverage each one another's work. Do we have another question over here? Okay, without further ado, that's it. Thank you very much.